Hey everybody, Mr. Wada here again, and today we're going to be going over how to calculate density. Right before we had lost our time in class to our closure of the schools, we were doing a lab on density by putting different objects into graduated cylinders and figuring out what the mass of those objects was and how much water they displaced. In measuring the difference of those two things, along with the density formula, we were able to figure out the density of those materials. So I figured it would be good to get some practice with that, since this week is basically us trying to finish off filling in the gaps and me really figuring out what everybody knew, because again, this was now my second actual week of material with you guys, so still have a lot to learn. But anyways, to start, I'm going to go over a couple of the answers on this sheet, but before I get to that, I need you to complete this on a separate sheet of paper and then take a picture of it and then upload that picture as your assignment. And I need you to write your name on the paper so that I can read it. And this is honestly just that I know whose work is whose, because the whole point of doing stuff like this is that I can try and figure out what people know and don't know. I'm not sure exactly how long we're going to be out of school and doing distance learning, but at some point I have to assess and see what people actually know. And I don't think it would be fair for me to do that if I wasn't aware of what you guys really knew before we got to that. So it's hard for me to know what review we'll need to do in the future if I can't do this stuff now and know who knows what. Alright, with that, so you're going to need to write your name on the paper so that I can read it, and then submit your picture as the assignment on Classroom. So, I guess I'll start by writing my name on the paper, even though I'm teaching it. In case you didn't know, my name is Matt Wada. It's Mr. Wada to you. By the way, if you haven't seen that, I don't know if it's TikTok or whatever, but there's a student who went around and asked all their teachers what they called all their teachers by their first name and then recorded their reactions. It was pretty entertaining. Alright, anyways, so first question for you guys is, what has been the hardest part of distance learning for you so far? And this is so that I can help make sure I know what I need to do on my end over here to make learning as good as possible given the circumstances. So that will do more good for me than you can possibly understand, because I've been trying to make sure that I have videos and different resources available to help, but it has been pretty obvious to me the past couple of days that there are some people struggling. So if you would just share that with me, that would be really helpful. So you can just put that at the top. The hardest part for the distance learning for me has been communicating effectively, because it seems like there are a lot of people who aren't doing the work so far and could benefit if we could talk person to person. And we can't do that the same way. So I tried to set up a Google Meet today, and that didn't go as planned. So, you know, there's lots of things that are difficult for me too. So just let me know. So my answer is communicating effectively. Also, someone had left me a comment that it would be easier if I used a bigger marker or a larger pen or something, and I know this marker isn't like optimal, but I need to go buy more, and this is what I had available when I was recording this, so I'm at least trying to address that. Alright, so to start, as for my end of this, I'm going to do the first two questions on that list, the block of aluminum one and the mercury metal one, and I'm going to teach you what the density formula is. And then the ones that are not in italics at the bottom here are the ones I'm going to ask you to do on your own. Also, you may have noticed this is a lot less work than previous days. That's on purpose, because there are some people that are making some things up from before still. So I'm trying to make sure that they have the time they need, and I need to figure out what's working and not working to make better work for you in the future. Okay, so anyways, to start, we need to know what the density formula is. And that is density equals mass over volume. Also, I hope you like the music while this is going on. This is the song I've been listening to while I've been setting up classroom work and stuff like that. Alright, so here's your formula. Density equals mass over volume. You will commonly see it rewritten as D equals M over V. My middle school science teacher, Mr. Ciccarini, my favorite science teacher of all time, he told us to remember it as density equals a broken heart. He had some like corny story about like what density was, and density did something mean to someone and it broke their heart. But if you look at it, M over V, if I connect these, would look like a heart. Okay, so that's your formula, and as long as we know what the different numbers are, meaning what the numbers in the problems mean, this actually isn't a very complicated problem. There's 3 different ways you can simplify this. You can solve for density, you can solve for mass, or you can solve for volume. The first one we have right here, density is mass over volume. If you want to solve for mass, you need to have mass by itself. It needs to say mass equals something. So to do that, you would need to move volume to the other side. In algebra, to get rid of something and move it to the other side of an equation, you have to do the opposite operation. So addition and subtraction are opposites, and multiplication and division are opposites. So we need to move volume to the other side. So instead of dividing, because it's already divided here, we have to multiply. So that would be mass equals density times volume. So that means you also have M equals D times V. Okay, so now we have mass and we have density. How about volume? Volume would take 2 steps. You would have to move volume over the same way as before, so multiply, and that would give you density times volume equals mass, right, which we have right here already, M equals D times V. We want volume by itself now, so we would need to divide this by density, and that would mean mass is divided by density. So your third version of this formula is volume equals, and like I said, dividing both sides by density here gives you mass over density. Okay, so those are the 3 different versions of the formula. And now for our 2 problems. So, a block of aluminum occupies a volume of 15 milliliters and weighs 40.5 grams. What is its density? So the first part is figuring out which version of the formula you want. And we had started doing this in class, but again, just making sure we really get this. What is its density? So it's asking us to solve for density. So that means we need to start with density equals. So we're going to use this version right here. D equals M over V. So D equals M over V. We have 15 milliliters for volume. So that means our 15 milliliters is going to go there. And we know it weighs 40.5 grams. So that means 40.5 is going to go there. That means we have density equals 40.5 grams, right? Because that's what's in the problem, divided by 15 milliliters. And then the final step is to calculate that. I'm using my phone as a calculator. You can do that too. There's nothing I can do to stop you from looking at your phone right now, right? So it doesn't really matter what you're using as a calculator. So we've got 40.5 divided by 15. Oh wait, it's upside down. There you go. So what that gives you is 2.7. The unit is going to be the parts that you already have here. It's grams divided by milliliters. So you'd have like that. Okay, so that was the first problem. That was the block of aluminum problem. The second one here says mercury metal is poured into a graduated cylinder that holds exactly 22.5 milliliters. So we already know we have 22.5 milliliters, and that's volume. So we've got volume. And then it says the mercury used to fill the cylinder weighs 306.0 grams. From this information, calculate the density of mercury. Okay, well, your first question should be, what are we solving for? So take a second and try and figure that one out. Okay, hopefully you came up with density, because it says calculate the density of mercury. So if what we're doing is calculating the density here, we're going to be just plugging in the mass and the volume. So again, we're doing the same type of problem as before. Density equals mass over volume. Okay, we've got 22.5 milliliters. And that's volume. And it even says it's poured into a graduated cylinder. Graduated cylinders help us measure volume. So the volume here is 22.5 milliliters. And it says it weighs 306 grams. So mass is on the top here. 306 grams. Plug that into your calculator. 306 divided by 22.5, and that would give you 13.6 grams per milliliter. Okay, so those ones are on the sheet there, but if you noticed, both of those follow the same format. Run out of space down there. And we haven't done one that solves for something different. So for the last one, we're going to be using a mystery block. So this block, we know its mass and we know its density, but we don't know what volume it takes up. So you have mass of 15 grams. This box, this block, whatever you want to call it, weighs 15 grams, and we know that its density is 2 grams per milliliter. Okay, well, we're trying to find the part that's missing. So if we have mass and we have density, that means the only part that's missing is volume. So out of the 3 versions of the formula there, we need to find the one that's solving for volume. So we need this one right here. Volume equals mass over density. Okay, so that would mean, if you take a look at the numbers you got here, your mass is 15 grams. So we have V equals 15 grams divided by the density. Density is 2 grams per milliliter. And this would give us 7.5. Okay, one thing we don't have though is what the unit is. So using the information on the page already in the previous problems, we can figure that out. So volume over here was milliliters. It was also milliliters over here. And if you notice, we've got milliliters down here. Volume's unit of measurement in chemistry is milliliters. So you got that there. All right. Hopefully this is helpful. You've only got a couple of questions there, and I'm going to just double check and make sure that those questions up there are the ones that I want to keep, but I'm going to make sure that we have one for volume, one for density, and one for mass. If you have any questions, just leave a comment on Google Classroom or send me an email, as some already have, and I hope you have a good rest of your Wednesday. Bye everybody.